Okay, so we are moving on in our algebra unit, which is solving equations. That's our main learning target with this unit. What you're going to be able to do today, you're going to be able to identify if a number is a solution to an equation, and you're also going to be able to make an algebraic equation given a word phrase. All right, so you need some vocab. An equation is an expression with an equal sign. For example, 2x plus 2 is an expression. You're just saying 2x plus 2. You can't solve that. An equation is when you can solve it. You better have it equal something. That's an equation. It's an expression. An expression is just a set of numbers with an operating symbol. 2x plus 2. I'm expressing 2x plus 2. An equation has an equal sign. I think of the root word equal, there's an equal sign in there. Equation must have an equal sign. An open sentence is an equation with a variable. So like today you're going to have to identify if an equation is true, if it's false, or if it's an open statement. And if it has a variable in there, it's open. And solution, when you figure out a solution, it makes an equation true. Okay. So we want to determine if equations are true or false, or if they're equivalent statements. We simplify both sides and verify if it's true. It's pretty easy to do this. So I do the left side and the right side, left, right. I figure out both sides and I see if they equal each other. So what's 24 plus 18?
42.
42. Does 42 equal 42?
Yep.
So true. Michael?
If the equation is false, then we put a slash through
Yeah,
the
sure.
sign.
Yep, absolutely. So 8 times 7 is 56. 56 does not equal, there's that slash equal sign that Michael was just talking about, does not equal 54. So you would say false, or no, or just leave it like this. 3 ways. False, no, cross out the equal sign. I'll take them up. I don't know if this is true. It's open for debate. It depends on what x is, doesn't it? So since I don't know if it's true, I say it's open. Right now. Eventually we're going to get to solving these. 32 divided by 8, 4. 2 times 3, 6. 4 does not equal 6. That's a false statement. Okay, the next one, 3y plus 6 equals 5y minus 8. Well, I don't know if that's true. It depends what y is. It's open for debate. So I would say open. Also, it has letters. That's an easier way. It has letters. Call it open. Okay, do you feel like you're okay with that learning target? Perfect. So let's move on to identifying solutions. So the first target, we are given 2 expressions, and then we see if they're equal to each other. Here I'm given an equation, and then I have to plug a value in to see if it's true or not. So what we want to do is plug the number in for the variable, and then verify. How they format this is where some kids get confused. The semicolon here, this says 32 equals 2x plus 16 semicolon 6. The semicolon means 4x equals 6. That's all it means. Or for x, or the variable, 4x equaling 6. So I put the 6 in there. And then I go, does 32 equal 2 times 6 plus 12? Does 32 equal 12 plus 12? 32 does not equal 24. So 6 is not a solution. Now you could go ahead and just do the equal sign with the slash in it. It's fine. Or false, not a solution. All equivalent statements. Okay, the next one here, 6m minus 8 equals negative 5. Semicolon a half. The semicolon just means for m equaling 1 half. So I put the 1 half there. So that's 6 times 1 half minus 8. Does that equal negative 5? What's half of 6? 3. Does 3 minus 8 equal negative 5? Yes. Yes. 1 half is solution. You don't have to be that fancy. I really am not that picky of a teacher. But that's really what we're determining. Is the number a solution? Yes, 1 half is a solution. Michael?
Could you just put true as well?
Yep, all equivalent. Okay, 5b minus 6 equals 43, semicolon 10. The semicolon just means make the variable the number after. So I'm going to put the 10 in here. Does 5 times 10 minus 6 equal 43? Does 50 minus 6 equal 43? 50, just kidding, 44. 44 does not equal 43. So not a solution. Hey, you love this. I can see it in your eyes. You're so stimulated by this. Put the 7 in. I'll hurry up. 4 times 7 minus 12, does that equal 16? Is 28 minus 12 equal to 16? 16 does equal 16. Yes, comma, 7 is a solution. I think I just like to write solution because it's fun. You know it's fun. You get to make that fun S and N. I love them. Whatever. Okay. Writing equations. I think that's our last learning target. So I have identifying if a number is a solution. Yep. And creating algebraic equations. Here we go. What you need to know with an algebraic equation is means equals. So, the sum of 3x and 2 is 7. So is means equal, so I say equals 7. What's sum mean? Huh? Just say it. Add. So I go 3x plus 2 equals 7, right? The sum of 3x and 2 is 7.
What would x be?
You don't know. You just leave it. Yeah, you can't solve it. Well, I mean, you probably could solve it, but we're not there yet. The product of, what's product mean? So I know I'm going to multiply. The product of 7 and, and this. Anytime you have another operating symbol, if you have two operating symbols, you're gonna have parentheses involved. You have two operating symbols. So I'm going the product of 7 and the sum of 3 and x. So I have to go this, the sum of 3 and x, times it by 7. So you have to tell your problem solver to find the sum first. That's why we use parentheses. Find the sum times it by 7. Is means equals 8. So the point of possible confusion would be, when do you use parentheses and when do you not? And anytime you have two operating symbols, you should use parentheses or vocab words. Product, sum, parentheses. Okay? 6 less than x is negative 12. 6 less than. I think there's somebody here. When we say less than, it's like less important, right? So you put it second. 6 less than x is negative 12. You remember? Less than, less important. Who told me that, Michael, of course. That's a good strategy. I shared that strategy with all my hours. Okay, last thing that wasn't part of my daily learning target. We're going to use mental math, which means we don't have to use algebra concepts to find solution. So I'm saying 2 times what gives me negative 2. This is mental. In my head, I'm saying 2 times what gives me negative 10. 2 times what equals negative 10? What is it? Negative 5. 2 times negative 5 equals negative 10. Now in my brain, I'm saying what minus 3 equals 10? What is it? What if I take 3 away from something and it gives me 10? What is it? 13. You totally knew it. It's 13. Where should I put that? I should erase this. It's 13. This is saying what divided by 3 is 5. What number divided by 3 is 5, right? 15. So 15 divided by 3 is 5. So you're going to have some sections today where you have to solve using mental math, and that's how you do it. Tables and solutions, I think it's a waste of time to create a big table when you can just most of the time do it in your head. Okay? So I'm going to just say, if they say a table or solution, to go ahead and skip any table and solution words. Okay?